Can you hear me and can you see my screen?
Yes, sir.
Okay, let us start. Today I would be talking about the instruction sets of 8051. Okay, so 8051 instructions. Basically, uh, we can divide the instructions in 8051 in five categories. In all, there are 111 instructions in 8051. Okay, I hope you understand what is mean by instruction. Actually, it refers to the command which is given to the microcontroller so that it executes some operation. Okay, and we can categorize these instructions into five categories. The first one, the first one is known as arithmetic operation set. Okay, the second one is your uh, logical operation instruction set. The third one is the data transfer instruction set. The fourth one is the Boolean operation instruction set. And the fifth one, and one of the most common, which is used for high-end programming, is the uh, program branching instruction set. Okay, so I would be talking about each of the instruction within these categories, and I will start with the arithmetic operation set. Okay, so as the name suggests, it involves instruction which are used for carrying out arithmetical operation like addition, subtraction, multiplication, and division. These are the four basic mathematical or arithmetical operations that can be carried out by the 8051 microcontroller. So for each one of them, we have instructions. For example, for let's start with the addition. So we have got add instruction. Okay, and add can be operated on various combination of operands, which I am writing it down here. Uh, it could be operands could be a and rn. Okay, where a is the accumulator and rn is any one of the general purpose register from r0 to r7. And what is the what happens when I use this instruction over these two operands? So this instruction basically add the content of the accumulator and the register. So if I have got 25h stored in A and I have got say 52H stored in R naught, and if I am executing the instruction add a comma R naught, then after the execution of this instruction, A will be having the addition of the content of the two registers A and R0. I had already told you that in A register, the result of the operation is stored. So after this instruction, the result, which is 72H, would be stored in accumulator. Okay. Now we can also use add in immediate addressing mode. I had told you that there are various addressing mode in 8051, and I showed example with the help of move instruction. Move instruction is actually comes under this uh, data transfer instruction set, and I will also talk about it later. But all the modes of operation that I talked for move are actually valid for many other operations also. Say, for example, the add operation. We can have all types of uh, all modes of operation possible in add also. So let me take immediate addressing mode, a comma hash uh, some hex number. Okay, say I think 25H. So that means add the content of A with 25 and store the result in A itself. Okay. So this is what is meant by add A comma hash 25. This is immediate addressing mode. Then we can have add A comma at the rate RI. Okay. So this is indirect addressing mode. So if I write, say I take, for example, I'm taking A equals to 25H, and say R1 is equal to say 52H, and say 52H has the content 32H. Fine. Then after the execution of this instruction, and say let me write here R1. Okay. I am not mentioning in which bank I am working. So by default, if I had not mentioned it, bank 0 is selected. So say for example, this R1 is of bank 0. Okay. And I am doing operation in bank 0. So add a comma at the rate R1. So what will be the result of this operation? Can anybody tell me? Can anybody tell me?
57H.
It would be. Can you
57H.
be a bit louder?
57H.
57H. So A has got 25 and the content of R1 is 32. Okay. So if I add 25 and 32, so what I will get? 57H. Okay. Fine. Then uh, okay, then I can have this type of instruction also. Say A comma 52H. So what will happen? Now the content of 52 is added to A. That means if A was earlier having 25 and 52 was having 32H, so these two numbers 25 and 32 gets added and the result would be 50 3 to 5 and 5 to 7, 57h. Okay, again 57h. So I hope it is clear, the operation of add. Okay, let's move to another instruction in the arithmetic operation set, which is add C. Add with carry. It is add with carry. So what it means? So the add instruction which you used here is used to add two 8-bit numbers. Okay, we can add only two 8-bit numbers. Say we are interested in adding two uh, in adding two 16-bit numbers. Can we do it? We cannot do it with the help of this add instruction, but we can do it with the help of this add and this add C. Okay, so let us see how it is carried out. I will be showing one example, and then it would be clear how add C is used. Okay, so let me move to a new page. I'm taking one example. I have to add uh, wait. Okay, sorry for the interruption. Somebody was actually at the door. I had to open it. Okay, so let's continue. So I was talking about the add C instruction. Add C. And we can use it in conjunction with add instruction to add two 16-bit numbers. So I would be taking one example. Let us try to add two numbers. One of them is 25F2H. It is a 16-bit number. And then we have a 3189H. This is again a 16-bit number. So definitely we cannot use add instruction to add these two 16-bit numbers. So what to do? So just see how I am adding these numbers. So first of all, what I do, I move. I hope you know what move do, although we would be again studying it in data transfer instruction set, but you know what it do. So move a comma hash 89H. Okay. So what will happen after the execution of this instruction? So a will have the value 89H. Okay. Then add c a comma hash 0F2H. Okay, so this is 89 and this is F2 here. So what we are doing, we are adding the lower uh, 8 bits of the two numbers, which we normally do in addition. First we add the last digit, then second last, and so on we proceed. But one thing we have to ensure that when we add these two number F2 and 89, if there is any carry, that needs to be added to the addition of these two numbers. Okay, so that's why we are using add c. Add c is addition with carry. So whenever if we add F2 and 89, so what would be the result? The result would be 7b and there would be a carry. So carry flag would be set cy equals to 1. Okay, so when you execute this add c command, so carry flag would be set. Fine. Now, again, one more thing I should mention here, that whenever we are using a number uh, which starts from an alphabet, so hex number may start from an alphabet. It could be A, B, C, D, E, F, any of the alphabet. We should always write a 0 before the alphabet when we are using when we are using uh, immediate addressing mode. Okay, and this is in order for the compiler to understand that it is working on a number, okay, and not a character. Fine. So that's why I had added this 0 in F2. And whenever the first operand, which is a number, is a character, and in hex we have character A, B, C, D, E, F, so we have to write 0 before it. Okay, then what I have to do, then I have to transfer this uh, the result of this addition of the lower 8 bits of these two numbers into another register. Say I am storing it in R3 comma A. That means this number 7b will now be carried to R3. Okay, then what I do, then I have to add these two numbers, the upper 8 bits of the 16-bit numbers. So what I do, move, what happened? Okay, move A comma hash 31H. So what this instruction do, A will now have 31H. And after that add C A comma hash 25H. Now these two upper 8 bits 25 and 31 of the 16-bit numbers get added, and the result is stored in A along with the carry. okay, along with the carry. So if there is any carry, so that carry is added to the addition of these two numbers, and which is identified by this cy. If cy is set in the earlier operation when we added f2 in 8 9, carry flag was set, so cy was now carrying 1. Okay, so this instruction add c, what it do, it adds 31 with 25, and it adds the carry flag content also, carry flag content. So if it is 1, if it is 1, then 1 also gets added to this sum. Okay, and the total, it comes out to be 57h. So if I add these two number, what would be the answer? It would be 577bh. Okay, and and the answer is stored in the upper 8 bits are stored in A here, 57, and the lower 8 bits are stored in R3. So please let me know you understood this process of adding two 16-bit numbers or not. Or if you have any doubt, let me know. Any doubt? Any doubt? Yes, I hope you are listening to me.
Yes,
Any
sir. No.
doubt? No doubt. Okay, let's proceed then. So this was all about the add and add C. Similarly, we can do add C with all the four modes of operation. Okay, is it fine? So add C, we can use add C as a comma hash. We did hash comma add data. We did this operation here, so we could have add C a comma at the rate ry also, and add C and a comma uh, the direct addressing mode, the direct address. So any of the operation is possible. Any of the modes of operation are possible in add C also. Let's move to another operation, arithmetic operation sub B. Sub B. So this sub B is subtract with borrow. There is no sub B instruction in 8051. We have sorry, we don't have any sub operation or sub instruction in 8051. We have only sub B instruction. Okay. Okay, so let us see how it works. So as the name suggests, it actually uh, do the subtraction operation, and from one of the operand, the second operand gets subtracted. Okay, so let me take up one example to understand how it works. Again, it works in all the modes of operation like immediate, register, direct, and indirect mode. In immediate addressing mode, we can write sub b as sub b a comma hash data. So this is immediate addressing mode. Say if I take one example, sub b a comma hash 25h. And what this operation means, that after the operation a will have the value a minus 25h minus the carry flag. Okay. Similarly, we could have sub b a comma rn or ri, whatever you like to call. So this is a register addressing mode. So we can have an example of register addressing mode as sub b a comma r3, r3 or r4, whatever it is. So after the execution of this instruction, a will have the value a minus r3 minus the carry flag. Okay. Then we could have the direct addressing mode sub b a comma a comma uh, direct. That means this is the address of the memory. Example could be sub b a comma 30h. So after this instruction, a will have the value a minus the content of 30h minus the carry flag. And finally, we could have the indirect addressing mode, in which we can have sub b a comma at the rate rn. An example is sub b a comma at the rate r naught, and after the operation a will have the value a minus now not the content of r naught, but the memory location pointed by r naught. Okay, so this is how we represent it: the memory location pointed by r naught, and then minus the carry flag. Okay, is it fine? So one thing you must be noticing here, that in sub B instruction, minus CY, the content of the carry flag, gets subtracted when this operation is performed. Okay. So when you are working with 8 bit numbers, okay, or 8 bit numbers, then you have to ensure that the carry flag is set to 0 initially. Okay, so it is better to add the instruction CLY, CLR, sorry, CLR, and CLRC to clear the content of the carry flag before you use sub B instruction, if you are working with two 8-bit numbers. But if you want to subtract to 16-bit numbers, then definitely you don't have initially you have to make it 0. Then when you proceed with the subtraction, then you can have the same type of operation as you have in add C. Okay, any doubt here? Fine. So let's move to another instruction, and it is very simple instruction. It is the INC instruction, which simply means increment the content of It may be A or increment Rn, any of the register. So if A was having 25H initially and I use INCA, after this instruction, A will have the value 26H. Similarly, if R1, say R1 was having 27H, and if I write INCR1, then after this instruction, R1 will be having 28H. As simple as that. Okay. Similarly, we could have direct, indirect, all types of addressing mode is again possible in case of INC also. So you can have INC 30H, increase the content of 30H by 1, or we could have INC at the rate R0, increase the content of the content of the register pointed by R0 by 1. Okay. All type of operation in INC is possible, all modes of operation. Similarly, we have another instruction called DEC, decrease, and this simply means decrease the content of this register A, or DEC RN means decrease the content of register RN, and we can have DEC 30H, decrease the content of 30H by 1, or sorry, DEC, or we could have DEC at the rate R0, that means increase the content of the memory location pointed by R0 by 1. So these four are very simple instructions. Okay. Now we come to two important instruction in this set. One is your mul operation, which means multiply. And mul operation is on the operand AB only. We cannot use any other register for it. Okay. So that means if you are interested in multiplying two numbers, one has to be stored in A and the other has to be stored in B. Okay. One has to be stored in A and the other has to be stored in B. You can use move instruction for that. Okay. And then after the execution of this instruction, what will happen? An 8-bit number multiplied by an 8-bit number will result in a 16-bit number. Okay. So the result will be stored in A and B itself. The upper 4-bit would be stored in A, lower 8-bit would be stored in B. Similarly, we have another instruction called div, and it also operates on the registers A and B. So div AB means A divided by B. Again, we have to store the number that has to be divided in A and the number which divides A in B. Okay. Say for example, we have 20H and 5H as two numbers. Okay. So this has to be stored in A and this has to be stored in B, and then we can use this operation. After the operation, we expect quotient and remainder. So quotient is stored in A and the remainder is stored in B after the execution of div AB instruction. Is it clear? Okay, fine. So I should stop here.